Hello. Today we are going to be taking notes on page 99 and 100 of your interactive notebook. The pages have been handed out to you, so you need to make sure you put them on the respective pages. The practice page goes on 99 and the topic page goes on page 100. As you'll see, the topic and essential question are written on the page demonstrated for you, so please pause the video and write those different features in. Once again, the topic is combining like terms. The essential question is, how do we know which terms can be combined? And we are looking at standard 6EE4. And you should be able to identify when two expressions are equivalent. And just some background information so we can remember. Don't forget that a term is a part of an expression. So expressions are made up of various different terms. Talked about that yesterday. And the first thing I want you to do is I'm going to use a highlighter. You can actually use a pencil to do this, or you can use different colored pencils or a marker. But I'm going to use 3 different colored highlighters today. And the first thing I'm going to do is I'm going to mark and identify in this equation the various the various terms within the equation. And we know that's an equation because there is an equal sign. And remember that equations are made up of expressions. Expressions are made up of terms. Terms can be variables, constants, coefficients. So in this case, we have 3 different terms. There are 3 different terms. And like terms have variables. Make sure that you can see this. Sorry. Let me get it right there. All right, so like terms have variables that are exactly alike. They are exactly alike. So they don't kind of look alike, they're exactly alike. And you're going to see some various ones that look alike, but they're not exactly alike, so they don't count as like terms. However, while the variables are exactly alike, the coefficients, or the numbers in front of the variables, do not have to be the same. And also remember that constants are like terms as well. The numbers without the variables are like terms. So let's look at some examples of like terms. So terms that are alike. And I'm going to put this in green because to me, I want to remember that if I see things like this, I can combine them. But I want to remember that using a red pencil, if they're unlike, I want to stop. I can't go any further. So if they're alike, I can combine them. If they're unalike, I got to stop, and I can't do any more in my problem. Okay, so let's first go with our green light, the things that we can combine. And the first one is we can combine them if they have variables that are the same. So like 2x plus 3x. They both have a coefficient and a variable. The variable is the same. So I can combine them to be 5x. 2 plus 3 is 5, and there's an x. So that is something I can combine. I could also combine it if it was w plus 3w. Even though that variable doesn't have a 1 in front of it, it is given that that is 1w. And if I add them together, because the variables are the exact same, I'm going to get 4w. I can even combine them if they are constants, like 5 and 1/2. I would just add them because they don't have, both of them are constants, they don't have variables, so that I can add them, and I would get 5 and 1/2. So those are all examples of places where I can combine like terms. Now, we also have unlike terms and where we have to stop. An example here would be if I were to have 5x squared plus 2x. Now, we might be confused here and think, oh, I can combine those because there's both x's. However, this one with the exponent is actually representing x times x. So it would be 5x times 5x, which is not the same as the x that we have. So we cannot combine them because there is an exponent. An exponent with a variable is different than a variable by itself. So I'm going to make a note that exponents make the variable different. Okay, now let's do another one. How about 6a and 6b? Well, obviously the variables are different, so that doesn't work. Can't do it. And finally, another example would be like 3.2 plus x. Well, I have a number or a constant and a variable. They can't be combined. You can't combine constants and variables. All right. So now that we know some rules and some examples of unlike terms, now let's do a practice. So we're going to go down to the very bottom of the page where it says simplify by combining like terms. And the first thing I want us to do is I'm going to take two different colors of highlighters and I'm going to mark the terms that are the same. So I have here a 3x, here's a 5x, that's a y, so I can't combine that one, but here's a minus 2x. And then I've got, here's a y, and here's a minus y. Okay, so now I've marked which ones are the different terms. So now I'm just going to add or subtract the terms to combine them. So on this one, I have a 3x, a 5x, and then I've got minus 2x. Okay, so to do this, I'm going to say, okay, well, 3 plus 5 is 8, 8x. Minus 2, it would be left with 6x. So for these x variables, I have 6x. Now let's do the pink. I have a 7y minus, because see this minus here, 2y. 7 minus 2 is 5y. So I've got 5y. This one. So now let's combine them together. 6x plus 5y would be my answer. And I can't go any further because those are different variables and therefore I cannot combine anymore. All right, now let's go to our practice page, which is on 99, so we can practice a little bit more. Okay, so on this page, what I'd like you to do is I would like you to start off by marking each term. And combine like terms to simplify. So it looks like this. There's an x, there's an x, there's a y, there's a minus y, 4x plus 2x, which is 6x, plus 5y minus 3y would be 2y. There's my answer. So I want you to pause the video, and I want you to now go through and solve the rest of them on your own, making sure that you mark the terms that are the same and that you then go through and that you make sure that you are, once you combine them, that you're putting them together once you figure out which ones are marked and identified as being like terms. You're going to finish the rest of the page and do all of the examples. I will put the answers for the various problems. I will put it on Haiku under this video so that you can check your answers after you're done. But make sure you do them all and that you know what you're doing. So thank you so much. I hope you pause the video or go back and watch it again if you have any questions. Thanks.